Okay, let's look at a little more complex problem from number 2. Now we're going to have the same problem as that second one we just did, but our dragster now has friction on it, right? So we still have the same 30 psi. We have the same diameter, 2.1 centimeters, and it's still 73 grams, but now we have a friction force that is 35 newtons, and we want to know the acceleration. So now if we have the friction force, we know we probably should get a smaller acceleration than that one we just got on that second problem, or that we got in the second problem. So if we look at our free body diagram again, we have our force of the air, but now we also have our force of friction. So that changes our sum of the forces equation. So when we look at our sum of the forces equation, we're going to make to the right positive, the direction the dragster is going. That would be the force of the air minus, because that's in the negative direction, the force of friction equals our net force. That equals the mass times the acceleration net. Now, we've already done, if you go back to that second problem, you can see how we calculated the force of the air because all of that stayed the same, right? So we know the force of the air. We got that one in the second problem. That was 71.688 newtons. Now, if we didn't have that, we'd have to go through, remember, and use our force equals pressure times area like we did in the last one. Calculate that pressure. We did a conversion on it, and then calculate the area of the cap of the dragster. But we've done all that in that last problem, so we'll just use that force of the air. But then the force of friction, it tells us in the problem, right, that it was 35 newtons, right? Remember? Right here, it says the force of friction on the dragster is 35 newtons. So that, having this already done, the force of the air already done, that simplifies the problem quite a bit because now we can just say that the force of the air is 71.688 newtons minus our force of friction, 35 newtons. And when we do that, that's going to equal the mass times the acceleration, right? Net. But we can do it all at once. Let's go back to our formula. Let's say the force of the air minus the force of friction equals the mass times the acceleration net. So I can just divide both sides by the m, right? So that'll tell me that the acceleration, that's the net acceleration, is the force of the air minus the force of friction all over the mass. So the force of the air, again, that was 71.688 newtons minus the force of friction, 35 newtons, all over our mass. Now remember, our mass needed to be in kilograms, right? That was from the last problem. So that's 0.073 kilograms. So now I can just do all that. That's my net force. And that's going to be 502.58. And remember, this is newtons. So newtons are kilograms times meters over second squared. So that means the kilograms cancel. This works out to be meters per second squared. That's the units of acceleration. So that makes me feel like we're on the right track. And so there we have it. 502.58 meters per second squared. That's our acceleration if we have friction.